Yes, sir.
Okay, now today we start from the, the place where we left yesterday, and I'm just telling you that how you are going to convert an empiric expression to a postfix form manually. Okay, but manual is not the way, and we should know how to use it and algorithm for this. Now let us try to show you that if I am going to do it manually, how does it work using a stack. Therefore, first of all, I will try to use an empiric expression, convert into an equivalent postfix, and then after that, I will evaluate that postfix in order to come to the conclusion that what we have done using manually is correct. Okay. Now let us start with the class today. Okay. Now let us check. Now today, let me first of all start with this evaluation of the postfix expression. Now let us try to do. Now, if I take expression like this, say 2 multiplied by 3 plus 5 divided by, say, let us do it like this, 3 plus okay, now this is expression 2 into 3 plus 5 plus 4 divided by 3. Now this is an empiric expression and I want to convert it manually using a postfix form. Now you know that first of all I have to do this bracket. Therefore this is the first one I will do. Then I will do this, I will take this bracket, second one, and then I will do this, the third one. Okay. Now once you are inside the bracket, you have to perform 2 into 3 first because multiplication comes before the plus. Therefore, in that case, this will be evaluated as 2, 3 multiplication. And then when I am going to use this, now this will be like this. Then what I will do is that I will be converting like this. 2, 3 is multiply, 5 plus. So this is the result after first. Then I'll just copy this over here, plus 4 divided by 3, and this bracket is already there. Now in that case, now this is the first operand, this is the second operand. Now what I will do is that I will convert like this, 2, 3 into 5 plus, then 4 plus. And this is the total result after doing 1 and 2, because the first operand, this one, the second operand is 4, and then the operator. Now in that case, the plus operator will go at this place, because you are going to use the operand 1, operand 2 and operator. And now you will have this 3 on, this one also. Now once you are going to convert like this, this becomes the first operand, this becomes the second operand, and the final expression what you will get, the postfix will be nothing but 2, 3 multiplied by multiplication 5 plus 4 plus 3. Now this is the final expression, because you take the first expression 2, 3 multiply sign plus 5 plus 4 plus. Then second operand is 3. Now in that case, just to remind you that this is the operand 1, operand 1, this is operand 2, and this is the operator. And this is the operator. Now, once I get 2, 3, this one, now in that case, if this is correct, now what is the answer for this? If you are going to evaluate it manually, it will come 6 plus 5 is 11, 11 plus 4 is 15, 15 divided by 3, the answer should be 5. Now if you are going to do it manually, it should give you answer is equal to 5. Now here, when I am going to take the final expression in the postfix form, you know there is no bracket and there is no precedence of operator also. Therefore, when I am going to evaluate this expression E, there will be no operator precedence. And therefore, what I am going to do is that the operator precedence will be taken care once I am converting from infix to postfix. Therefore, in this expression, there is no need to check that multiplication comes before plus or division comes before and so on. Therefore, it is precedence free plus it is bracket free final expression. Now let us try to evaluate this, and if I get the answer is equal to 5, you will agree that these two are same. Now you will agree that these two are same. Now let us try to evaluate this expression. Now I will take this. The expression is say 2, 3 multiplication. This is the postfix.
Excuse me, sir.
Yes.
Sir, before you start evaluating the that postfix expression, sir, I want to ask that, sir, in the algorithm of this, sir, the conversion of infix to postfix, sir, how like we are using manually, no? We are using manually, how we can use the stack to form the algorithm of this one?
Okay, that is
So
the algorithm I will do after this. I'm trying to do the easier one first. Then I will try to convert the exact infix to postfix by using a stack. Therefore, right now I will not use a stack because the one which I did now is just a manual way. But this manual way has to be done by using the algorithm which uses a stack. Now even this one will contain the stack. Now the algorithm which I am going to do is algorithm evaluate postfix. This is the algorithm which I am going to do now. Is the algorithm evaluate postfix. And evaluate the postfix algorithm will take an expression in the postfix form. And
sir, excuse me, sir.
Yeah.
I want to know about the algorithm which is changing the infix to postfix expression.
That I will do. Just after this, I will do that. Don't worry.
Okay.
That's a lengthy algorithm. Therefore, first I will try to make sure that you understand the easier one. Then I will do that. That's obviously that's the next algorithm which I will cover. Now, if this is the expression what I am getting, now first of all, what I will do is that I will first of all add. Now let us try to see. Now this is the input. This is the input. Now once I will be writing the algorithm to convert to infix to postfix, and then I will evaluate this postfix, I will get the answer. Okay. Now what I will do is that I will add the right parenthesis at the end of expression. What I will do is that I will add a right parenthesis intentionally at the end of expression. Why? Because this parenthesis acts as a sentinel value. That means how will you know where the expression ends? Now for that you will be using one of the particular thing which does not appear in nothing. Now in that case you can put either a bracket, you can put a hash, or you can put a comma, you can put a semicolon. anything, whatever you feel like, which will not appear. Now I already told you in a postfix the bracket will not be there. Therefore, I am just adding this. In the practical, when you are converting this algorithm into a program, it will be a /0 because you will always terminate that with a /0. Now, what I will do is that in the second step, I will scan the expression. Let us take it E. I scan the expression E from left to right. Character by character. Okay, I'm going to do it until I'll write like this. Until this bracket is found. Until this bracket is found, right bracket is found. Now this is nothing but a loop. A loop it starts from say 2 and will keep on going until I find the thing. Therefore, when you are doing it programmatically, you have to write a for loop or any other while loop, any loop which is starts from the beginning and keep on and works while not equal to that character value is maybe the brackets or maybe you put a /0. Now here what you will do, there are two things you will do. What you will get in this, you will get only two things. Either you will get an operator or you will get an operand. Okay, nothing more than that. Now here, if what will happen, if you are getting an operand, if you are getting an operand, you have to push it. Now, if we get an operand, then push to stack. If I get an operand, you push it into a stack. Okay. Now let us try to show you a stack over here. Now here I got 2. Now 2 is an operand. Now in that case I will push 2. Okay. Then I will just use, I will go forward. I get a 3. Again 3 is an operand, therefore I will push 3. Then I get a multiplication sign, which is a operator. Now in that case, if I get an operand, I will push it into a stack. If I get an operator, now the second is that if we get an operator, then what you will do is that you have to do two things. First of all, what you have to do is that you pop the 2 elements from the stack. Now in that case, you do 2 things. A, pop 2 elements from the stack. Now you will pop 2 elements from the stack, where the first element what is popped is, let us put into B, and the second thing which is popped, let us try to call it A. Now what I will do is that I will be popping 2 elements and then I will apply them. Then in that case I got 2 1, and then what I will do is that I will apply say A, and then this operator what I am going to get with a say B. I will say then perform this A, B. I'll perform this one, where A is the A is the operand at the top and B is the operand which is at the bottom, which is at the bottom. Therefore, in that case, what I am going to do is that when I pop 3 out, this will act as B. When I pop A out, A will become A. Sorry, 2 will become A. Okay? Therefore, okay, I'm just sorry. Now this is one. I'll pop 2 elements from the stack, then perform this operation B into A and put the result into a stack. And put the result into a stack. Okay. Now, what is the meaning? I got this one. Then what I am going to do like this, I first of all got 2, then I got 3, then I got this. When I get this, I'll pop it out. Then when I'm going to pop it out, what will happen? I'll just change the board. Now here, when I am going to, this was the stack which I took initially. This was the one. Okay. Now, when I am going to do this, you are going to pop it out. Therefore, I will have 3. Then I will have 2. And I will have this operator. The operator is multiplication. You will get answer 6. You remove these 2 over here. Then once you are going to pop it, this will come out. This will come out. And then you will have like this. Then you push 6 over here. Now 6 will come. Okay. Now let us try to do it like this. The expression which I got was this one. Then I will get 5. Now that this is the end. Now what you are going to do is that you are going to evaluate this and then put the result into back. And therefore I will say, okay, I'll make it let us. I could have put into say I could have done A here and I could have done say B. Could have taken 2 steps. That A pop the 2 elements from the stack, and then B perform this operation and put the result back to stack. Okay. Now let us try to evaluate the things which I got is here 2 in. Therefore, I will get say this for the expression 2, 3 multiplication, then okay. Now I did this one. I did this. Then I get 5. What I will do? I'll push 5 over here. Then I will get plus. I will pop 5 out. The 5 is out. I'll pop out 5 out. Then I will also put 6 out. Then I will apply the one which is nothing but a plus. I will apply over here, and this will become 11. I will pop it out. Therefore, when I am going to pop, this is going this 2 will go, and when I am going to push, this will be nothing but you will get say 11. I pop this 11, push this 11. Then I get 4. I push 4 over here. Then I get plus, again I get this 4 over here, then I will get 11 over here, and I will add this, I will get 15. I will pop these two out, therefore I will be popping these two out. And then what I will do is that I will be pushing this 15 over. 15 will come. And then I will get 3, therefore I will get 3 and push 3 over here. Then I get a slash or a division sign. Now when division is there, I pop both of them out. I will get 3 over here. Then I will pop 15 over here. Apply this one. You get the answer is equal to 5. You have popped this. You have popped these two out. Therefore now these two will go. And now what you are going to do is that you will get the result as 5. You are going to push 5. And now you know I have added an extra bracket over here. That's what I did. I added extra bracket. Now once I am going to put this extra bracket, what happens is that you are going to find that I encounter a bracket. I encounter a bracket. Now in that case, the loop, this will have to be little bit changed. Therefore, what you use that this algorithm scan the expression from until this is found. Now this is found, the loop will go because the loop will now it will break. Now in that case, I just made a small mistake. I use the fifth line over here. So what I will do is that I'll put this before I will use the fifth line. Now when the loop breaks, pop the only value present in the stack and this is the output. This is output. That means once I encounter a right bracket, I'll pop the only value from there, and therefore in this case the output will become nothing but equal to 5. I will get the output to be equal to 5, which indicates that this should have been the output. If output is 5 is correct, and when I evaluate the infix, I also got the 5 output as 5. It indicates that the equivalent postfix and that infix are same. Okay. Now, if this algorithm is correct, you must have noticed that I never used a precedence anywhere. I never used a precedence anywhere. But you might ask, where did I take the precedence into consideration? That I will be doing when I am converting an infix to postfix. Therefore, our next algorithm will be how to convert an infix to postfix. Therefore, if this is correct, that how I am performing that. Of course, when I converted this one to an equivalent postfix, I used all those precedence brackets, everything was taken over there. Is this clear? That this algorithm, how it works? I'll just tell you explain you once again. It's a very simple algorithm. What you do is,
Sir, in algorithms, you said that. Sir, in algorithm, excuse me.
Yes.
Sir, in algorithms, you say that when we encounter the right parenthesis, then we remove the value from the stack and give it as output. No.
Correct.
After encountering the right parenthesis, we pop the value from the stack and give it as output.
Correct.
Okay.
Okay. Now, one thing what you should have noticed very clearly, that I used a very important word over here, which you have to see it very clearly. I used the word only. That means there should be only one value in the stack. If the stack contains more than one value, or if the stack doesn't contain any value, it indicates two things. One is that you might have the expression what you got might not be correct. Therefore, when I am going to encounter this one, when I encounter the right bracket, I should have only one value. I should have only one value. Otherwise, it will also detect whether the expression is correct or not. Now let us try to show you, just before I start with the other one. Let us take one expression like this. I take some expression like this. Say 2. Suppose I take expression like this. Suppose I take expression. Now let us take this question. I do not know whether it's correct or not, but I apply the algorithm. Okay, let us take this question which I got, and I put a like this. I maintain a stack. Now here I got 5. I pushed 5 over here. I got 4. I pushed 4 over here. Then I got a multiplication sign. I popped them out. Therefore, what I did, I popped them out. This one is 4. Then I again popped the other one out. I another popped this one out. I will get 3, 4. I will get say 4. I will get 5. Apply this one. I get 20. I push 20 over here. Then I got 6. I push 6 over here. Then I got 3. I push 3 over here. Then I get plus. Then I get plus. Now what I did, I popped 3 out. 3 will come here. Now 6 will come here. I will get a plus. Therefore I will get 9. And here I will pop these 2 out, and I'll push 9. Therefore 9 will come here. Then I get a minus. Minus is there, but I pop 9 out. 9 will come here. Then I pop 20 out. 20 will come here. And then I will get a minus sign. It will give you 11. And I pushed 11. Therefore, in that case, what I did, I pushed 11. Okay. Now I process this one. I process this, and this. And then I will. Now here, what I am going to do, when I am going to, I also process this one. Okay. Now, when I encounter the multiplication sign, now what will happen? I'll pop 2 elements out. Now the one element, when I pop out, 11 comes here. But when I am going to pop the second element, it generates an underflow. Because once I encounter this, once I am going to encounter this element, I have to pop 2 elements. Now, once I pop the first element, I get 11. Once I pop the second element, I get an underflow. It means that this expression was wrong. This expression was wrong, and therefore
Sir,
this was not.
sir, no. Okay, sir. Sir, we have got the 11 up to -1, no? Then we have pushed it. We have popped it into the stack. Then again 4 is remaining, sir. We will pop 4 also. Then we will get multiply.
Just a moment. Just a moment. If I am wrong, okay, let me do it once again, so that you might. Okay, let me see. You are correct, maybe, but I am pretty sure that it's not correct. Okay, let me do it one. Maybe this might be. Okay, let me put a plus sign over here. Okay. Now it's correct. Now what I'm going to do is that I'm pushing 5, I'm pushing 4. Then I did this one, I did this one. When I get multiplication, what I do is that I am going to use this. I got from here, I will get 20, I'll push 20 over here. Then I will get 6, I'll push 6 over here, I'll push 3 over here. Then when I did this one, I did this, and Then when I get this plus, I pop this 2 out. I pop this 2 out. And then I am going to push 9. Then I get minus. I will get, say, 9 will come here, 20 will come here. Therefore, I process this minus also. And therefore, what I will get is that I will get this 11. Okay. I also process this 11. Then I got 4. I pushed 4 over here. Now I get multiplication sign. Now 4 will come here, 11 will come here. I will be doing this. I will get 44. Now once I get 44, I will pop these 2 out. I'll pop this out, 2 out, and I am going to push 44. Now once I get this plus sign, I will get this plus sign. Now in that case, I pop over here. I pop 2 elements over here. One is 44. The second, when I pop it out, will give you wrong. Will give you a underflow, and it means that this expression is wrong. Therefore, in that case, okay, that's what's correct. What you said is here. Therefore, what I'm going to do, this expression which I took was the wrong expression. It was wrong. Now, one thing what you should know, that how many operands were there? 1, 2, 3, 4, 5. And how many operators were there? 1, 2, 3, 4, 5. They are obviously, the number of operators should be 1 less than the number of operands. Therefore, in that case, this is an easy one to do. But even if the number of operands and number of operators are correct, your expression might not be correct. Let's take another example like this. If I take expression like this, say if I take 2, 5, multiply, say 6, say plus, say 3, 4, 5. So how many operands are there? Operands are there is operands is equal to 1, 2, 3, 4, 5, 6. Operators 1, 2, 3, 4, 4, 5. No, this is correct. But is the expression correct? Now, how can you do this? You have to maintain the stack. Obviously, I will first of all push 2. I will push 5. Now, when I get this, I have encountered over here. If I get this one, I did this one, I did this one. Now, once I will be getting into, I will pop this out. 5 will come here, 2 will come here. You will get answer equal to 10. And what I am going to do is that I am going to put 10 over here. I am going to put 10 over here. Now, once I get this one, again pop 2 elements out. Now there is only single element. Therefore, once I am going to get this one, I will generate an underflow. I generate an underflow. And when I generate an underflow, it means that whatever the expression which I got is wrong. Therefore, it may not be true that if this condition is holds, the expression is true. The position of the operator as well as the operand is an important aspect. For example, I might have expression like this, say 2 multiplication, say 3 into plus, then say plus, then plus 4, 8. Now here this contains 4 operands and 3 operators. But again, this is wrong. The expression is wrong because you should have operand, operator. Now this doesn't hold over here. It doesn't hold over here. And therefore, in order to detect whether the expression is correct or not, you have to take this algorithm, you have to run this algorithm to find it out. And therefore, it is not necessary that in order to detect whether the string is correct or not, you have to use this algorithm. If it is not only to evaluate the POSTFIX, but also to explain, also to test whether the expression is correct or not, whether the operators and the operands are at the correct positions. Now, any expression like this might be wrong. Now, if you are going to take it into expression like this. Maybe by looking also you can say, but if I say 2, 3, 4, 5 multiplied by like this, and then I will say 6, 7, 8, 9, and then say multiply like this. Like this. Now this might be correct or this might not be correct. You will only know when you are going to evaluate a stack. Now this might be correct, this might not be correct. You can only know once you're going to evaluate it. You push 2, then push 3, push 4, push 5. When you get the multiplication, pop 2 out and again push it, and you keep on going like this. Now this is the how you are going to check whether that's the thing is there or not. Now just what I'll do again, I'm going to use the algorithm. Now let us try to do the other algorithm. But what you were asking, therefore I am going to write an algorithm in fix to postfix. Conversion of infix to postfix. Okay. Now in that case also I maintain a stack. I maintain a stack. Now this again told yesterday that this stack has to be maintained by you. Okay. Now here, let me first of all run the algorithm to show it, and then you can very well write the algorithm. Let us take an expression like this. Take an infix expression. Let us take like this. Say if I take the expression like this, say if I take say 4 then plus 2 multiplied by 5 minus 3 divided by say 10. Let's take like this. An expression like this. Okay, this is the expression which I am talking about. Now in that case, this is the expression, this is the infix. Let us say I is equal to this is the infix expression. Now this is the correct expression. Right now it's correct because you find the brackets are perfectly matching and the operators are between two operands. Okay. Now I'll just try to show the output now. And the algorithm is very simple if you understand the logics over here. Now, first of all, what I will do is that I will put an extra bracket over here. I'll put an extra bracket over here. I'll put an extra bracket. That I just put extra bracket from my side. In the I infix expression, I put extra bracket. And in that case, what I am going to do is that I am going to add a left bracket in the stack. Now, what I will do is that I'll use in the stack, I will be using like this. I will be using that. I'll put an extra bracket over. These two things I did extra bracket at the end of the expression and an extra left bracket. Now just you will understand that why did I put a right over there and left over there? Just because of the fact I want to balance it. Once I put extra right, I will have to put extra left also in order to balance those two. Now what I am going to do, I am going to scan this. I am going to scan this. Scan the expression I. This again character by character. Now once I am going to scan the I, what all things I will get? I can get what? I can get a left bracket. I can get a right bracket. I can get an operand, or I can get an operator. Okay. I can only get these things. That means I can only get this one, or I can get this thing, or I can get an operand, or I can get operators. Anything, nothing more than that.
Excuse me, sir. Sir,
Ah,
Sir, as you said that we here we have used the right parenthesis at the last, so to balance it, we have used the left parenthesis in the stack. But in the previous algorithm, sir, we don't use the
because we,
left parenthesis, right?
because in that stack we never push the operands. Sorry, we never push the operators. We only push the operands. But here it will be a different case altogether. Here I will be pushing only the operators over here. Okay. Now the algorithm is very very different from that. There I was pushing all the operands in the stack, and once I get an operator, I used to pop the operands out. But here it's totally different one. Now this is acts only as to make sure that when I put extra right bracket in the expression, and when I will get that extra right bracket, I must have a corresponding left bracket for that. Okay. Now let us try to run the algorithm and show you that how it will work. Now, first thing, if I get an operand, if I get an operand, now let us take this. This is the postfix expression. This is the equivalent postfix, which initially contains null, which contains nothing. It contains a blank. Initially contains a blank. Now what I am going to do is that if I get, now let us try to, you just take the statement what I am writing. Before in the algorithm I will write in maybe today or maybe the next class, but I will show you how it works. What I will do is that if I get an operand, I will just add it to postfix expression. That means if I get an operand, I will add it to the postfix expression. Therefore, if I get say 4, I will just put 4 over here. If I get 2, I will put 2 over here. Okay? Then if I get a left parenthesis, this is the left parenthesis, this is the left one, this is the right one. If I get the left parenthesis, I will push that left parenthesis in the stack. Okay. Now here I got a left parenthesis. Now what I will do is that I will push it into a stack. Now I run the algorithm simultaneously. Then again I got 4. Now as I told you, it's an operand, therefore it directly add 4 over here. Okay? Now I got an operator. Sorry, I got an operator. Now here you have to do many things. You do it carefully. If I get an operator, you have to repeatedly pop the operators from the stack, such that I will pop all those operators in the stack which are having equal or higher precedence than this operator. I have to repeatedly pop from a stack, and I will pop all those operators. I will keep adding into the expression until I pop all the operators which are having higher or same precedence as the operator I have found. Now it means that if I get a plus, I have to pop all the operators which are having higher precedence than plus or equal precedence than plus. Now the precedence what is defined over here is little different from the Bodmas rule. In the Bodmas, you say bracket of course is there, and then you say here D, M, and A and S. The division, multiplication, addition, and subtraction are there. Suppose if I take these 4 operators. Otherwise, you can also take that power. You can also take the power or any operators which you find. Now here the rules are little different. Here the division and multiplication are at the same level, whereas addition and subtraction are at the same level. I am talking about the concept which is being applied in the case of expression, any language. Now here these are at the same level, and A and S is also at the same level. But if you find a power one, this will always be higher precedence. Now in that case, when I take plus, addition is having the same precedence as plus. Sorry, subtraction, minus. Similarly, if I get a multiplication, it is the same precedence with division or vice versa. Now in that case, when I get a plus, I pop all the operators from the stack having higher or equal precedence than plus. You find there is nothing over there. Therefore, I cannot pop anything out. Since, but even if I can pop or if I do not pop, I have to push that operator in the stack. That means if I could not pop, no problem. But I have to push this. Therefore, what I do is that I push plus over there. Then I get 2. Since it's an operand, I put into the stack. Sorry, I put in the expression. Okay. Now I get a closing bracket. That is right brackets. Now this is the fourth one. I already explained you the left bracket. Already explained about the operand. It has to put over here. Already explained about the operator. It has to be put in the stack, but with the condition that all the operators which are having equal or a higher precedence should be popped out from there and put into the expression, and then I get a right bracket. Now once I get the right bracket, what I have to do is that I have to pop all those operators over. I have to pop all the operators from the stack until I get a corresponding left bracket. Okay? Then what I do is that I got a right bracket over here. I pop plus out and add it over here. Then this will go. This will go. Then I also pop the left bracket from there, but I cannot add into the postfix. I discard it. Therefore, what I will do is that I will pop this one out and discard it. Therefore, nothing to do. I'll just discard it. Then I get multiplication sign. You know, it is an operator. Therefore, I have to pop it out. Nothing to pop. Therefore, I'll put it like this. I'll push it there. Then I get a left bracket. You know, the left bracket has to be pushed in the stack. Therefore, I put a left bracket. This one. Again, I take another left bracket. Again, I push it over there. Then I get 5. 5 is an operand. Therefore, you have to put into there. Then what I am going to do is that I am going to put 5 over there. Then I get minus. Minus an operator. You have to pop all the operators from there, but there is no operator at the top. Then what I will do, I push minus. Then I will get 3. 3 is an operand. You put it 3 over there. Then I am going to get the then I get the right brackets. You don't know that when I get the right bracket, I pop the operators from there and keep adding to POSTFIX. Now here, what I will be doing, I will pop this minus over here and put it over here. Then I will also pop this one out. I will pop this one out and then discard it. And we discard it. Then I will get this, the slash. I will put the slash over there. Because then I get 4. I will just add 4 over here. Then I will get the brackets. When I get the bracket, I pop this slash over here, add it over here. And therefore, what I am going to, I will add this over here. I will discard this also. I will discard it. Then I get a multiplication sign. I'll push. Now here is the thing. What I've been telling you. Sorry. Okay. Now once I get this multiplication sign, now the question comes. I have to pop the operators which are having equal or higher precedence. The top of the stack, you find it itself as a multiplication sign which is at the equal precedence than the star. Therefore, I will not directly push the star over there. I will have to pop those stars from there and put into the expression. Now, in that case, while handling this multiplication sign, I have to pop this out. I'll pop this out. And therefore, I will push it, pop this out over here. Therefore, what I am going to, I will pop this out, and then I have, well, once I popped it, I cannot pop anymore because already it's exhausted, and I will push this one again. If I will push this again. Now this one which has come over here was the one which came from the stack. The one which is they pushed over there is nothing but the one which we countered. Then I got 3. I put 3 over here. And then once I am going to use the other, when I am going to use this right brackets, I am going to pop this out. Therefore, this will come here. Therefore, this will come here, and I will remove this and discard. I will remove this and discard. Now, at this position, you find the stack is empty, and this indicates that this postfix what we have done is correct. It is correct. Now, once you are going to convert this one using, you are going to convert using this. You are going to convert using the manually. You will find that you will get the same effect. You will get the same effect. You just try to convert it using manually. You will find that it is the same one. What we are getting. Now let us try to show you whether it works or not. Therefore, let me try to do it manually. Here, this will become 4-2 star plus. Correct? This will become 5-3 minus. Okay. Now we are left with this one, and we are left with this one, and left with this one. Now there are 3 operators: multiplication, division, and multiplication. Obviously, all 3 are having the same precedence, but the first one comes over here. Therefore, but without that, you will have to process the bracket first. Therefore, what I will do is that I will write 4 and slash, and this is the equivalent of this. Now, in that case, you get this star over here, which is nothing but the one, and you will get, say, I will do this star again. Therefore, I will be. And if you do this one first, therefore this will become nothing but 4-2 plus 5-3 minus 4 this one, and then multiply. And then you will have this. This is the first. This is the first operand, and this is the second operand. And therefore, what you will do is that you will put a 3 over here and a star over here. The 3 will come here, and star will come here. And you will get 4-2 plus 5-3 minus 4 slash star 3, which is nothing but, now if you find over here, if you just check it out, which is nothing but this and this are same. These are same. It means that once we are doing it manually or we are doing with a stack, the results are same. And this indicates that what we have tried to do using a stack was correct. Okay. Now let us try to do it. I will take another expression, and I will show you that how it's going to work. Now let us take another expression just to repeat the things once again. Let us take this like this. Say 4 plus 2 plus 3 plus 5 minus, say, 6 minus 2 into 3 into 4, like this. Okay. And what I am going to do is that I am going to add x. Now in that case, I will maintain the stack. And I'll put extra brackets over here and then this bracket over here. Okay. Now I get, this is the postfix equivalent. I get left bracket. Therefore, what you will do, you put a left bracket. Then I get 4, I'll push. Then I get a plus, I push plus. Then I get 2, I'll put it over here. Now this I process. Then I get plus. Once I get a plus, I have to pop the operator from the stack. Therefore, in that case, I have to pop this 4 over here and it have to put over here. I put plus. And then once I pop them, I should have popped more if there would have been more. But there is only one. Therefore, what I am going to do, I popped it out, and with that, what I am going to do is that I am going to push this one. I am going to push this one. Now this will be, now in that case, this will be pushed. Now this is pushed. Now get I 3, I put 3 over there. Again, it comes plus. I will pop this. I will pop this one out. The plus will come here, but I will push this plus over there. I'll push this plus over there. Therefore, again, this has come back. In that case, it will be nothing but I will again push this plus. Then when I get 5, I will put in like that 5. Then I get a right bracket. You pop this 5 out. You pop this 5 out. So this 5 comes here. And just discard this also. Discard this also. Then what I get a minus sign. I push the minus over. Then I get a left bracket. I again put a left bracket. Then I get a 6. I push 6 over. I put 6 over there. Then I get a minus sign. I will put a minus sign over. Now here, try to understand it. Then I get a 2. I will put a 2 over here. Then I get a multiplication sign. Now here is the crux you have to take. Once I get this multiplication sign, I have to pop all those operators which are having higher or equal precedence from the stack. But here what I find, I have a minus which is on top of the stack, which is having a lower precedence than a star. And therefore, I cannot pop minus, because I have to pop only those operators which are having equal or higher precedence, not the lower precedence. Therefore, in this case, you cannot pop minus out. And therefore, what you will do is that you have to push a star over here without popping this minus. Then you find 3, you put 3 over here. Then you find a star. Now a star is there, but on the top there is already another star. Since it's having the equal precedence, I have to pop this star out. Pop this star out and put it over here. And then I have to push this star over here. I have to push this star over here. Then I got 3. I'll put a 3 over here. Similarly, I again get a star. I pop this one out.
So not 3, it will be 4.
Pardon?
So I think 3 twice, sir.
So it will be 4.
Fine. And then when I get that brackets, what I'm going to do, I will take the one out, and therefore I will be able to do this. If what I will do is that I will just be erasing this one. And once I get the other brackets, I will be able to push this one, and I will take this out. I will take this out. And now this is the expression. Now one thing, what is there, if you are going to manually convert it, now if you are going to manually convert this, what will happen? You are going to find that there are 3 plus, but you have to perform the one which comes there. Therefore, you have to perform this one first, then this one as second, and this one as third. Therefore, it will be 4, 2 plus. Then it will be like this, plus 3, plus 5. Now, again, I will do this one. Therefore, it will be 4, 2 plus 3 plus for this one. Then it will again this plus 5. Now it will be again 4, 2 plus 3 plus 5 plus. So this is equivalent for this. Now if you see over here, you find that
टाइम ओवर हो गया है.
you see this is the same. Good. If you keep on doing like this, you will end up in getting that. Now if you are trying to do just 2 minutes, if I take this one, you have to do which of the operators you have to do first? You have to do this one first. Now let us try to show you. This you have to do first, this you have to do second, and this you have to do third. Now in this case, this will become 2, 3 star. Now this will become say 4 star, and this will become say if you are going to do like this. Now this will become like this. Now this is nothing but this one. Then you find that this is the one.
Sir, we can do 4 or 3 also at the first time.
No, to do it the first operator, we will scan it from left to right to do the one which comes first. Therefore, when I am going to scan this, the one over here, this one, is coming before this. Therefore, the scan must be done left to right only. And then you find that there is over here, then you have a plus over there, and therefore this value which is going to go will go there. I think I missed the one. Therefore, this minus would have been, therefore, they would have been 1 minus also. Because with this minus also, this will also come here. That is the whole algorithm. Now, it's easy to write the algorithm. You have to write it the same way that you have to take that scan the expression from left to right. If you get an operand, put it into the expression. If you get an operator, pop the operators which are having higher or equal precedence with that, and keep adding to the expression. When you get a left bracket, push it into the stack. When you get the right bracket, pop all the operators from the stack and keep adding to the expression until you find the corresponding left bracket. Remove the left bracket, but don't put into the expression. And with this, at the end, you will find that this particular stack must be blank when you will encounter the sentinel value what you have put down. This is the sentinel value. This is the sentinel value. Sentinel value means the end of the expression value, any sentinel value. And once you encounter that thing, your stack must be empty. Okay. Now this is fine. You will just keep on practicing. Now I just give you 2 questions for your practice. Question number 1: write an algorithm to check whether the infix expression is balanced or not. Now this question has come in the previous exams. If I'm just showing you the questions, these are the questions which has come in the last exams, that you have to check whether the infix expression is balanced or not. Now in that case, the meaning is that, let us take an example. If I have like this, now to check whether this is balanced or not. Now obviously by manually you can do it, that you find that these brackets are matching. Therefore in that case it is easy for you. This is matching, but for this one there is no corresponding left brackets. Similarly you find that this is matching. There is no corresponding for this. There is no corresponding left bracket. There is no corresponding left bracket for this. And you find that this is unbalanced. Now this has to be detected by the algorithm. Just modify the algorithm such that you can try to find it is balanced or not. Or might be you find that there is a bracket somewhere over here. There is a bracket somewhere over here. Again, this is wrong. Now in that case, I might have like this. How many left brackets are there? 4. 1, 2, 3, and 4. How many right brackets are there? Of course, it's the same one. Now, if you find one, two, say three, and say four. You just take, if I erase one of them. And we can erase one of them. No, 4 and 4 are correct, but it is not balanced. It is not balanced. Therefore, your algorithm should say that this infix expression is not balanced. And this is the output what you want. That once you are going to use this concept, your algorithm should detect this. Now stop at this point and make sure that you just take some example and try to do it yourself. You take some example.
Sir, please upload the recording also.